1 2 1 2 1 2 1 2 1 2. Woo! Also the same thing for the part A. So we are trying to do a simultaneous, iteration. We say, or if I in range, the same thing. Basically, our I should stop wherever. Because if we find any instance where I and A don't have, any instance where they work together, which is impossible because obviously the root of a value is going to be the root of the value is going to be the lowest common, the initial lowest common um, ancestor. But if we find an instance where we don't see any, we don't find the path to A, obviously we must have failed by now. So basically, it's impossible not to have I within the same range, right? Because obviously we have a path now. And then one more condition we says, and it says while A and B, A at index of of index of I is equal to A at index of B. So this is the kicker. This is the kicker. So basically what it's saying is that uh imagine we find we're looking for this direction is the direction to D. The direction to E would be left and right, right? So we have something like this, right? We have something like this. Gosh, yeah. So we have something like this, right? So we are saying this condition is met because the index of 0, L and L is equals to are the same, but L and R are not the same. So immediately we find this index where the two of them don't match, we should break the while loop and basically return the current. So 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 basically what we are saying is that if we know that okay, this L and L the current is where the current node is situated as of right now, and then we check the next guy and it doesn't have that this thing, then the common ancestor between this point, this L and this right, would be this point over here, right? Because the two of them stop going the same direction at this point, and which is what we'll see that is synonymous here as well. The two of them stopped going to the same direction the moment they split. That's where their ancestor lies, and that's what we find out here. So we say direct equals to path to A at that index, and then we see if direct is equals to left, then our current should go to the left, and if our direction is equal to the right, our correction should go to the right. Our current should go to the right as we increase I. So basically, what we are doing is we come here, we have the direction, we have the direction. We say if this guy is equal while I is not greater than the length of this guy and not greater than the length of this guy. These are the three conditions we need to be met. So we will say if the first two are you know are there, and then the third one is now that the two of them are also equal, then we should go to the left. So we go to the left, which is B. Now we check again, is I now we also increase I will become I was equals to 0 for the first instance, and now because we've gone to the left the first time, I increases. We could see that here where our I increases by 1, and then we are now at B. So we say L and R are no longer the same. So that means what do? We break out of the while loop, and once we break out of the while loop, we return the current because our current is, as of this point, is still this guy over here, right? Because we've just, it's still the B. We've just gone to the left, and this guy is our current ancestor, and then we return current as our current ancestor, and basically that's where how we get our solution for the lowest common ancestor for this guy in brute force, right?